So good morning to one and all present here. Today, agenda of my session is today I am going to present the topic called signal flow graph. The first agenda, signal flow graph introduction, followed by Mason gain formula and the transfer function of the system, overall transfer function of the system, followed by the problem which we may able to solve. So, signal flow graph. The introduction of signal flow graph. Generally, the signal flow graph which is utilized to find the overall transfer function of the system, which is constructed by S.J. Mason. And the second thing, the advantages of signal flow graph is it is very easier method when compared to block diagram reduction technique, and the overall transfer function can be computed easily through the Mason gain formula, which has been given as transfer function of the overall system transfer function T, which is nothing but 1 divided by del summation of k p suffix k to del suffix k. The overall transfer function can be concluded through this Mason gain formula, and it can be represented graphically from signal flow of the system. Then the general transfer function can be expressed as general transfer function of the system can be expressed as T, which is equal to output of the system divided by input of the system with the Laplace transform with the overall transfer function as, that is a overall initial condition as 0 initial condition, which is equal to 1 by del summation of k p suffix k del suffix k, where the p suffix k, which can be represented as the gain of the kth forward path, gain of the kth forward path, which can be expressed as the p suffix k, which can be expressed as the gain of the kth forward path, where k represents a number of forward path. K represent number of forward path in the given system. Next, where del is represented as, del is represented as del, which is equal to 1 minus sum of individual loop gain, sum of individual loop gain plus sum of all possible combination of loop gain of two non-touching loops, two non-touching loops minus summation of all possible combination of loop gain of three non-touching loops, and so on. It repeats so on. So this is the expansion of overall transfer function of Mason gain formula. This will be the expression. The last thing, del suffix k. The last thing in the overall transfer function is expressed as del suffix k, which is nothing but the gain value of paths which is not touching the kth forward path. So this will be the overall transfer function of signal flow graph through Mason gain formula. Now we will solve the problem based on this Mason gain formula step by step. So whenever the problem is given, the first step is need to find out the overall transfer function of the system which has been given here. So it begins with node, the numberings which has been represented as node points, the number 1 till number 8, which is nothing but the node points of the signal flow graph. And if the node point which has been indicated in the question, then you may proceed directly the problem. If it is not indicated in the question, you need to represent the node point of each problem. So it begins from 1 and ends with how many numbers of nodes, that is junction points, you need to number it. Then after numbering it, you need to proceed the problem. Whatever the gain which has been given in the node, it must be noted. And the third important thing, you need to have a look on assigning the input as well as output for the transfer function or for the given diagram. So the first thing, you need to give the input value, assign the input value, which is nothing but R of S. The first point, first node which has been indicated as R of S, and the 8th node which has been indicated as output node, and it has been indicated as C of S. After assigning the input node as well as output node, then only you need to proceed the signal flow graph problem. So first step is to find out the step number 1 for any Mason gain formula or any signal flow graph which can be concluded with the transfer function, that is transfer function. You need to give the transfer function which is nothing but t equal to 1 by del summation of k p suffix k del suffix k. In that, the first step is to find out the k value. For any given problem, the first step is to find out the k value and its gain. So k is nothing but number of forward path. So in order to check from the diagram, in order to check the number of forward paths applicable in the given problem, so how to check is from node 1 till node 8, how many ways to reach the node 1 to node 8, which must follow forward path. The arrow mark indication of each node should be in the forward path. Each node will be indicated in the forward path. The same arrow mark direction which has been represented as forward path. In case here it has been represented as reversal flow. So for any number of forward path finding, you need to check only the forward path which reaches from the input node R of S to output node C of S. So the first forward path, you may look on the diagram from the node 1 till node 2, the forward path which is looks like from 1 to 2, the arrow mark indication which looks, and similarly from 2 to 3, the arrow mark indication. The forward path is nothing but from node number 1 to 2, this is nothing but your forward path. In case 2 to 3, 2 to 1, which has been represented as a reverse path. So these are the indication point. Based on that indication point, from node 1 to node 8, all the nodes should reach till 8th node, which should be in the forward path. So node 1 to 2 forward path, node 2 to 3 forward path, node 3 to 4 forward path, node 4 to 5 forward path, node 6 to 5 to 6 forward path, node 6 to 7 forward path, node 7 to 8 forward path. So the k equal to 1 first forward path reaching from input to output, which should be shown in the figure. So all straight node which has been represented as forward path 1, 1, 2, 3, 4, 5, 6, 7, 8, and its gain, you need to give its gain value also 1 G1, 3 to 4 G2, 4 to 5 G3, and 5 to 6 G4, 6 to 7 G5, 1. So this is the forward path number 1, starting from R of S input node to ending with C of S, which is nothing but output node. All the arrow mark which looks in the forward direction, So starting from 1 position to 8 position, there is no reversal, only the forward. You need to look on the diagram and search for forward path alone from input node to output node. So the first forward path. Is there any other possible combination of reaching input node 1 to till 8 node? Is there any other possible combination? You need to check, you need to verify from the diagram. So you need to look on 1 to 2 and 2 to 6, 2 to 5, the next forward path here, and 5 to 6, 6 to 7, 7 to 8. This is another possible combination of forward path. So next forward possible, that is next possible combination of forward path, which should be represented by k equal to 2. How many numbers of forward paths available in the problem you need to identify. First forward path is looks like straight line, which starts from 1 to 8. The second forward path is a curved path from 2 to 5. It belongs to curved path and reaching the value till 8. The second forward path also should be represented in the diagram or a graphical representation should be given or provided. So from 1 to 2, next 2 to 5, reaching till 7, 8. So and its equivalent gain has to be marked 1 G6 and G4, G5, and finally 1, and you must indicate the input value R of S as well as output C of S. So this is there any other possible combination you need to check in the diagram, that is the signal which flows from point 1 to till 8. Is there any other combination? You may check 1 to 2, 2 to 3. This is the reversal path. So this combination will never come, and this combination also you may check 1 to 2, 2 to 3, 3 to 4. This is the reversal possible. So there is no other possible combination of forward path reaching from node 1 to node 8. There is no other possible combination. Only the k value which is limited to 2 values. One is k equal to 1 and k equal to 2. So the total number of forward paths in the given problem which has been 2. k equal to 2, and you need to figure out the k equal to 1 forward path as well as k equal to 2 forward path. So without which you couldn't have any marks. So the next you need to go with the other parameter findings. The other parameter findings are after finding out the kth forward path, how many numbers of forward path, you need to give the gain value. So the gain value, how to find out the gain value? So after finding, you need to put the tick mark on the transfer function. So the first value which we were find is nothing but a k value. So k you may able to tick it, and next parameter you may able to round it off, that is p suffix k. Next parameter we may able to find, so that is p suffix k value, which is equal to p suffix k is nothing but forward path gain value, forward path gain value. So you may have two numbers of forward path, k equal to 1 and k equal to 2. So k equal to 1 is one possible combination of forward path, and k equal to 2, which is another possible combination of forward path. From that you may directly give the gain value. So how to find out the gain value is nothing but p suffix k, where k equal to 1, then the k value is indicated as 1. Straight away you may give the gain value p suffix 1 equal to multiples of all these gain values, which gives the gain value. The path number 1, it begins from 1 to 8, reaches till 8, and in the arrow mark, forward path arrow mark itself, you may find the gain. All those gain should be multiplied, and the overall gain of the forward path k equal to 1, which should be provided, that is p suffix 1, the forward path gain 1 k equal to 1, which is written as p suffix 1. Then the gain value of all those things, which should be multiples. So starting from 1 to 2, you may find 1. Multiple of 2 to 3, you may find the gain value as g1 dot. Next 3 to 4, the gain value is g2. This figure you may able to view. Next gain value g3 from 4 to 5. Next gain value from node 5 to 6, g4, and the last gain value from 6 to 7th node is g5 dot 1, the last 7 to 8. So all those multiples which can be given as p suffix k value. So p of 1 equal to g1, g2, g3, g4, and g5. This is your forward path 1 gain value, p suffix k value. Next forward path gain value of second forward path, that is k2, which is given as p suffix 2. The k value which has been p suffix k, where k equal to 2, which has been substituted, then it becomes p suffix 2, which is equal to the node 1 to 2, you may find the gain value as 1. Next 2 to 5, you may find the gain value as the forward path gain value as g6, and from 5 to 6th node and 7th node, the gain value as g4 and correspondingly g5 dot 1. So this will be the second forward path gain, that is p suffix 2, which has been given as g6, g4, and g5. So this will be the second forward path gain value. So after finding the p suffix k's, you may able to give the tick mark in the transfer function, overall transfer function. So far in the signal flow graph problem, we were find out the k value as well as p suffix k value. K value is nothing but a forward path gain, and the p suffix k value is nothing but forward path gain. And next thing, we may able to go with the delta value calculation. Delta value calculation. So delta is nothing but which can be expressed as so delta, which can be expressed as 1 minus sum of individual individual loop gain, individual loop gain plus sum of gain products of sum of gain products of all possible combination of all possible combination of all possible combination of two non touching loop. Next, minus sum of gain products of all possible combination of three non-touching loop, three non-touching loop. So based on this expansion, we may able to find out the individual loop. First of all, the third step, you need to find out from the delta, you need to find out the individual loop first, then you may go with the gain, individual loops gain. So how to find out the individual loop from the given signal flow graph? So any loop, the starting point and the ending point should be same with all forward or reversal arrow mark indication, with either all forward or all reversal. So you may check with here the problem. You may consider the node number 3. From node number 3 to node number 4, it has been represented as forward path, and node number 4 to node number 3, again it has been represented as forward path. Starting from node 3, node 4, and it again reaching node 3 with all closed path, that has been considered as individual loop number 1, individual loop number 1, individual loop is nothing but the closed path which has starting and ending value with the common node. So it begins with the 3, node number 3, arrow mark which has been forward path, and 4 to 3 again it reaches, and it is a circular path with all arrow mark reaches node number 3, 4 again 3. So and you need to give the that is overall gain value G2 as well as H1, that is minus H1. In the question itself it has been regarded as minus H1. Next individual loop, individual loop number 2, individual loop number 2, next you need to find out the individual loop number 2. Again you start with the node number 3, node number 3 to node number 4, node number 4 to node number 5, again it reaches number 3. So again the next which is the closed path, so the next closed path, so the next individual loop which has been given as node number 3, 3 to 4, and again 4 to 5, all forward path, and reaches again third loop, that is third node G2, G3. You may check from third node it reaches the fourth node, and again fourth node to fifth node, and the arrow mark indication third node, it reaches with the third node, it is correct. If the node representation is just opposite, means it does not reach the third node, it is opposite node, then it is wrong. So all the arrow mark which should be in the forward, and it has to reach the third node. So that means it has been correct. Then second individual loop number which has been given, and the third individual loop, the third individual loop. You need to check all the combination, all possible combination of individual loop. So the third possible combination of individual loop you may check with 2 to 3, again 3 to 4, 4 to 5, and again this loop you may check, that is it is opposite combined, so then it will never come. Next other loop from here, here you may check, this is also the not possible combination. And is there any other possible combination that the particular node which gets closed with the loop? Is there any other combination? Just to check. One, loop number 1, loop number 2, this combination will never come, and this combination, this combination also you may check. Here it reverses, here it forward, and here it reverses, then it won't come, since the two arrow mark which is in opposite direction. So only two, that is individual loop number 1 and individual loop number 2, in the problem only the two individual loop is possible. So other than two individual loop, there is no combination of other possible combinations. So after checking all possible combination of individual loop, then only you move on to the finding of individual loop gain. Individual loop gain value, individual loop. For the individual loop, you need to give the gain value, which can be represented as the new variable p. P is nothing but the gain. For individual loop, the first combination of individual loop, the first one represents first combination, the second one represents individual loop, which is equal to all this gain value must multiple, and which has been given, that is G2 dot minus H1, which can be given as minus G2 H1. Similarly, the gain value of a second individual loop, this is the number 1 loop and this is number 2 loop, the second combination, that is individual loop, which can be represented as 1, and the second combination of individual loop, which is equal to all gain value which should be multiplied, that is G2 dot G3 and dot H2, where H2 were given as H2 gain, which has been given as negative sign, so then it has to be combined, then P12, which is equal to minus of G2 G3 dot H2. So this is the second gain value of individual loop, and this is the first gain value of individual loop. After finding individual loop, you may represent tick mark, and after finding the gain value of individual loops, you may represent tick mark. After overall findings of individual loop gain, you need to sum it. The third step is to sum. After finding individual loop numbers 1 and 2, you need to have the gain values. After representation of the gain value, then only you may go with the sum, then you may able to sum with the value of a delta, which is equal to 1 minus sum of individual loop gain, 1 minus P11 is the first individual loop gain and P12 is the second individual loop gain. So then delta, which is equal to 1 minus P11, which has been represented as minus of G2 H1 minus of P12, which has been written as minus of G2 G3 and H2. Then then you may go with the sum of gain products of all possible combination of two non-touching loop. Is there possible combination of two non-touching loop? Next you may have the look on two non-touching loop possible combination. Is there any possible combination of two non-touching loop combination? After finishing the delta value with the 1 minus sum of individual loop gains, first of all you need to find out the individual loop number, then you need to give the value of gain. Finally, you need to sum all those gain. How many numbers of individual loop gain you are getting, that you need to sum. Then you may extend this delta formula. The delta formula, in the delta formula, next step is to find out two non-touching loop. From the individual combination of loop number, here any loop which has been non-touching, that you need to check. That is based on the node number itself, you may able to check. Here you may find the node number 3 and the node number 5, that is 4, and here you may find the node number 3 and the node number 5, 4. You may able to merge with these loops, these two loops in the single line. Then whether it is not touching or touching, you need to check the combination. So if you are merging with this graph, here you may merge with this graph. If you are merging with this graph, then it node number 3 and node number 4 both are touching, then it is not having the possible combination of two non-touching loops, So in the delta value can be restricted to this alone. If you are not getting two non-touching, then there is no possible combination of three non-touching loops. So these two things will never available in the given signal flow graph. For the above signal flow graph, you may have only this delta value. That is, after finding this delta, you may able to give the tick mark in the overall transfer function T, which is equal to 1 by delta summation of k p suffix k del k. So in that you may finish to the k value finding, you may finish to the p suffix k finding, and overall delta finding. Then the final step is to find out del k. So stop பண்ணிக்கங்க சார், ஸ்டாப் பண்ணிக்கங்க.